Okay, guys, so we're looking at solving equations, solving quadratics using five that are in like five different formats. So if I were to look at n squared equals 21, and I would try to do what we were doing before with quadratics, in which we were trying to factor it, I would get n squared minus 21 equals 0. Well, that's not factorable. Like, I know that negative 7 and 3 give me 21, and negative 1 and 21, and 3 and 7. I mean, that all gets me that, but that I can't factor it. So how else can I solve it? And that's where we're going to talk about the idea of square roots. So what I want to do is when I have n squared, I have the variable by itself, so I'm going to square root both sides, and I get n to be the square root of 21. Now, if I plug in 21 into this equation, because I can always check it, when I square the square root of 21, I get 21. But I can also square negative square root of 21, and I will get 21 too. So what happens is when I take the square root of something, I will always get two solutions, the plus or minus version of it. What I would try to do is try to break down 21, which is 3 and 7, so that doesn't break down anymore. Now, if I look at b squared equals 73, the same idea is used. So I'm going to take the square root of both sides. So I get v equals plus or minus square root of 73. Because if I were to square root of 73, I would get 73. And if I were to square the negative square root of 73, I would get 73 too. So that checks what I'm looking for. So in order for this to work, I need to get the square by itself. So if I look at question 3, I have an a squared, but it's not by itself. So I'm going to add 4 to both sides. So I end up with a squared equals 9. So I want to get rid of the square, so I'm going to square root both sides, and I get a to be plus or minus 3. We'll do the same thing with number 4. I want to get p squared by itself, so I'm going to divide both sides by 10. So I get p squared equals 22. I'm going to square root both sides, and I get p to equal plus or minus square root of 22. Now, 22 doesn't break down like I could try. 22 breaks down to be 2 and 11. Both are prime, so that would be my final answer. I'm going to ask you guys to try 5 and 6. You guys can ask me if you have questions. I'm going to jump to 7 and 8 with you guys. So 7, the same idea is applied. I want to get the a squared by itself. Division tends to be my last thing that I worry about, so I'm going to add 5 to both sides. So I have 7a squared equals 175. I'm going to divide both sides by 7, and I get a squared to be 25. I'm going to square root both sides, and I get a to be plus or minus 5. We'll do the same thing with number 8. I'm going to subtract 5 from both sides. I got 4p squared equals 180. I'm going to divide both sides by 4. So I end up with p squared equals 45. Square root both sides, and I got p equals plus or minus square root of 45. But if I look at 45, 45 breaks down to be 9 times 5, 3 times 3 times 5. So my final answer would be p equals plus or minus 3 square root of 5. I'm going to ask you guys to try 9 and 10 for me, and the answers are on the next video.